In today's video, we are going to be converting standard form numbers into scientific notation. So just a quick recap. Remember, scientific notation is used by scientists, astronauts, doctors that resemble really large numbers or really small numbers. And it's basically a simpler way to write them. So we have these numbers, really large numbers in these cases. And what we're going to do is we're going to convert them to scientific notation. Now, remember, there are three parts to scientific notation. There's a number out in front multiplied by a power of 10. All right. And the power of 10 is basically used to determine how many spots we move the decimal point when we convert it to scientific notation. So, first thing I always try to find is where is my decimal point? So in this problem, we know with any large number, the decimal point is at the end. Okay, and I just draw a little decimal there. And then what I do is I read the number from left to right and see where the first non-zero digit is, and then draw a little arrowhead after it. So I read from left to right. So starting from left to right, here's 3, my first non-zero digit. And what I do is I put in a little arrowhead right there because this is how far my decimal point has to move to this spot. Then what I do is I count the number of decimal spots it moves by drawing little hops or hoops. So I have 1, 2, 3, 4, 5, 6. So to write this number in scientific notation would be 3.14, because that's where I'm moving my decimal spot, times 10 to the power of 6, because that's how many hops it moved. 1, 2, 3, 4, 5, 6. And that is my answer in scientific notation. Okay, let's do that for the next one. Put in your decimal point. You read from left to right and see where the first non-zero digit is. Here's the first non-zero digit is 1. So I put my arrowhead right here, right afterwards. And I count how many hops. 1, 2, 3, 4, 5, 6, 7, 8. So it's 1.05 times 10 to the 8th. All right, let's keep it moving. Keep it moving. All right, we have another number. Put in our decimal. Read it from left to right. 4 is my first non-zero digit. Put my arrowhead after that. 1, 2, 3. And actually, you know what? Before I do that, you could count if you don't have to do the individual hops. Like I know every comma has 3, right? So we have 3 here, 6, and then one more, 7. So we have 3, 6, 7. So that's where my decimal spot is moving. So it would be 4.07. Oh, 007. Careful. There's 2 zeros in between that 7. Times 10 to the, we said it was 367 power. So it's 4.007 times 10 to the 7 power. So those are really large numbers. Now we have also really small numbers. And the same goes with these, except they're going in the other direction. And they already have the decimal point. So the decimal point's already here. Again, you read the number from left to right and see where's the first non-zero digit. So I'm reading this from left to right, and here's the first non-zero digit. So I'm going to go right after it and make my little arrowhead and move it 1, 2, 3, 4 spots. So my scientific notation number is 4.12 times 10 to the, since it's a small number, -4 power. And there is my answer. So a really large number is going to have a positive exponent. Really small number is going to have a negative exponent. Basically, when you're making this number you're moving this decimal spot to the right. It's a negative. All right, so let's look at the last one. Again, all right, I already know where my decimal is right here. All right, first non-zero digit, you read from left to right. You go, keep going, keep going, keep going. 6, all right, that's my first non-zero digit. Put my little arrowhead afterwards. I go 1, 2, 3, 4 spots. So it's 6.039 times 10 to the negative fourth again. All right. Didn't mean to do one with the same exact exponent as the last one. All right. Actually, you know what? We're going to do one more because of that. Just in case. All right. So I'm going to have 0.01001. There we go. All right. So I move this here. So I have the decimal here. Read from left to right. The first non-zero digit is right here, 1. So I put the arrowhead right after it. And then I move how many spots? 1, 2 spots. So your answer would be 1.001 times 10 to the negative 2 power. All right, and that's how you write it in scientific notation. So a negative exponent, it's going to resemble a really small number. A positive exponent is going to resemble a really large number. Remember, you read all these numbers from left to right. So to determine where the first non-zero digit is, you always read a number from left to right, like you're reading a book. All right, so that's it for today's video. Thank you for watching, and always remember, whether you're solving for X or Y, always give math a try.